All right, what's up, y'all? Sean, owner and lead tutor of Math Swap Tutoring, and today we're going to talk about finding the derivative of logarithms. Okay, so logarithms are pretty interesting. Logarithms essentially allow you to work with with exponents and whatnot, and help you to. It's a way to find like an exponent of a particular base number. Sometimes I know for me personally, I have to rehearse them a bit just to kind of make sure I remember them right. But anyway, logarithms are kind of cool. And I hope you think so too. But anyway, before we get started, remember, if you need math tutoring, you can schedule a free consultation at this link here below. Remember that we have weekly SAT and ACT math practice. You can go to patreon.com/math swap tutoring. And then don't forget to subscribe to this YouTube channel and like and share this video. All right, now, so when it comes to finding the derivative of logarithms, first of all, remember the natural logarithm, which is ln of x, okay? So natural logarithm is where we're gonna start this, this conversation here. All right, so first of all, natural logarithm is just a different way of writing a log base e of x. So remember, whenever you're talking about a logarithm, you are asking yourself, the result of a log is essentially the exponent, the power of the base number, which is e, that will give you whatever x is. That's what's going to be the result of a logarithm, okay? So again, when you add, so let me write this. So if you were like y equals natural log of x, what you're wanting to find out is y. And y is the power of the base number e that will give you x. And this is interchangeable with this right here, e to the y equals x, okay? Just interchangeable with that. What power of the base number will give you x, and that power is y. All right, so anyhow, the derivative of a natural log, denoted this way, can be found this way. The derivative of natural log of x is 1 over x, okay? Now, the general form of a derivative of a natural log with a constant is as follows. So derivative of the natural log of ax is also 1 to the x. So the reason why I started with this is because it ultimately doesn't matter if you have a constant there or not. But here's why. You have to remember the chain rule in this instance. So let's say we didn't know that the derivative of natural log of ax is 1 over x. What we would do is we would apply the chain rule. So let's take this over here and act like we didn't know that the derivative was 1 over x. We would apply the chain rule, which is, remember, the chain rule is going to be like the derivative of the outside times the derivative of the inside. So we're going to let ax be equal to u. I don't always do the u thing, but sometimes it's more helpful than other times. If it helps for you to kind of go ahead and make, let me write this stuff down. So df dx equals df du times du dx. Okay, so that's really what the chain rule is right there. All right, now, so we're going to let ax be equal to u, and then f of u is going to be, therefore, with a u substituted in there, natural log of u. Okay, so we're gonna find the derivative of d of f of u, and then we're going to multiply that by the derivative of u here. So df du remember that f of u is natural log of u, so the derivative of that is going to be 1 over u times du dx. So that's the derivative of actually u here. So the derivative of that is going to be a, okay? So now let's go ahead and substitute back in what u is. So u is just a over x. So that's times a. And if you notice here, the a's will cancel out. So you have the a up top and the a on the bottom. And then, therefore, you see that the derivative of natural log of x with a constant on the front is still 1 over x. So I just wanted to prove that to you. All right, so that's that. So let's go ahead and I'm going to erase this just to kind of save some space here. Make sure you pause, rewind, all that kind of stuff, whatever you need to do. Now, if you want to find the derivative of a logarithm with a different base, first, remember this. So, okay, so we've built these two things here. So keep these in mind. So now, if we want to find the derivative of logarithms with different bases, first of all, remember this: the log of x with base b is going to be equal to the natural log of x over the natural log of b, whatever that number b is, okay? So this is how you essentially, this is another way to, like, I guess, essentially convert that to natural log form, okay? So natural, or to change the basis of what I mean to say. All right, so that said, if you want to find the derivative of a log with a different base, that's going to be equal to the derivative of natural log of x over natural log of b, okay? Now, and all I did was just substitute in, log base b of x with what it was actually equal to, natural log of x over natural log of b. So now, next thing we're going to do is we're going to pull 1 over natural log of b outside, and there's times the derivative of natural log of x. So why did I pull that on the outside? Because 1 over natural log of b is really a constant. It's a number is what I mean to say. It doesn't have like an x in there. So it's going to end up kind of just staying there anyway. That's what happens. If you need to use the, like the, what am I trying to say? Like the product rule, to kind of prove that, you can, but we just go ahead and pull out the number to the outside because we know the number is going to stay there. All right, so you got 1 over natural log of b times the derivative of natural log of x. We know the derivative of natural log of x is just 1 over x. So that gives you 1 over natural log of b times 1 over x, or a final answer of 1 over x natural log of b. So the derivative of log base b of x is going to be equal to 1 over x times the natural log of b. Okay? That's what we just built there. All right, so let me see what else I wanted to say in this video before I gave a few examples. Okay, all right. Also, so the final thing I want to do is just kind of write down a couple of things here that I have here in my notes. Remember, if you need to copy notes from this video, remember I actually do make my notes downloadable on my website, mathswaptutoring.com, but you have to subscribe to get access to those. mathswaptutoring.com/subscribe to get the downloadable math notes. All right. So finally, remember that, or actually just note that the derivative with respect to x of b to the x power is equal to b to the x times the natural log of b. And then the derivative with respect to x of b to the negative x is going to be negative b. Okay, now see I have an error in my notes. To the negative x times natural log of b. Okay, so these are things to note as well. Now I've talked in a previous video where I talked about finding the derivative of exponential functions, about the special case where b is equal to the constant e. And in that case, the derivative of e to the x is just e to the x. The derivative of e to the negative x is just negative e to the negative x. Because you end up taking the natural log of e, and we know the natural log of e is just 1. Okay? All right. So now I'm just going to leave these things up here, and I'm going to do a few examples. So let's first take the, let's first do this example. So derivative with respect to t of t times the natural log of t. So remember the product rule here. These are examples. So it's going to be the first times the derivative of the second. The derivative of natural log of t is just going to be 1 over t plus the second one times the derivative of the first, which is just 1. So you have these cancel out, leave you with 1 plus natural log of t for a final answer. All right, so that's example 1. Let's do example number 2. We're going to do the derivative with respect to x of the log of x with base 10. So remember from what we talked about, I guess I forgot, I didn't leave it up. Remember from your knowledge of logarithms that this is how you change the base. So it's going to be the derivative with respect to x of the natural log, the natural log of x over the natural log of 10. So let's pull that 1 over natural log of 10 to the outside times the derivative with respect to x, natural log of x. So that ends up being 1 over natural log of 10 times 1 over x, or 1 over x natural log of 10. Now keep in mind, I could have just gone straight to this right here, but I just went ahead and went through all the work again, so hopefully it helped you to see that. And then finally, one more example here. We'll do number 3. It's going to be the derivative of 2 to the x, okay? So just looking at our formula up here, so to speak, for finding the derivative of an exponential, then that's just going to be 2 to the x times the natural log of 2, okay? All right, so hopefully this is pretty straightforward. Obviously, you can kind of go a little bit more detailed and have examples with different bases, or maybe kind of throw some cosines or product rule, quotient rule, stuff like that in there. But the main thing is that now you know how to take the derivative of logarithms. Make sure you like and share this video. Make sure you subscribe and stick around, because I am regularly posting videos. All right, y'all have a good one.